So D, interpret the slope and the intercept. Let's look at sort of what exactly the slope and the intercept mean. So number one, we'll have to write our equation in terms of the actual variables, not just our y and our x. We're actually going to put in what our variables are. And in our particular example, the data that we're using, we're looking at the data for birth rate per 1,000 people and life expectancy in years. So there it is. So that's the two variables we're using for our IV and DV in this particular example. First thing we'll do is analyse the slope or the gradient or the gradient of that line. So the slope, or B, predicts the change in the dependent variable when the independent variable changes by 1 unit. So basically, if my independent variable is going up by 1 unit, then how much is my dependent variable changing? We'll see that for our specific example in a minute. So the 1 unit might just be in centimetres or minutes or years or whatever it'll be. So your report should read like this. On average, insert my dependent variable, it either increases or decreases by whatever my B value is, for an increase in my independent variable by 1 and then whatever the units are, centimetres, minutes, years, etc. We'll come back to a specific example in a minute. So if B is positive, if our slope or our gradient is positive, that'll happen if our dependent variable increases as our independent variable increases. But if B is going to be negative, a negative gradient, that'll happen if our dependent variable decreases when our independent variable increases. We'll see some more examples in a minute. The only other thing you'll need to know is the intercept, the point that the y-intercept, the point it's crossing the line, is going to predict the value of the dependent variable, or our y-axis, when our x, or our independent variable, is 0. So the report for that should read like this. On average, dependent variable, when the independent variable is 0, is, and what it is. Let's look at an exact example of that. So, step 1, I said to you we need to write the equation in terms of the independent and dependent variable. So that's here. Life expectancy is 105.4 minus 1.44 times the birth rate, instead of y equals 105.4 minus 1.44x. So instead of y and x, we've put in life expectancy and birth rate. There are variables for the data that we're particularly using. So the slope, here's the slope report that I wrote here for you, but instead I've filled in the blanks. I might just put them side to side for us. So on average, that's this bit on average, life expectancy, that's my dependent variable, and in this case, life expectancy in countries, will decrease, because it's negative, it's going down, will decrease by, and here's my B value, 1.44 years, for an increase in, and here's my independent variable, birth rate of 1, birth per 1,000 people, that's my independent variable. Yeah, there you go. And so that my unit there is my birth per 1,000 people. So I'll just read that again for you without this. On average, life expectancy in countries will decrease by 1.44 years for an increase in birth rate of 1 birth per 1,000 people. And then our intercept report, here's our intercept report, just side by side for you. On average, here's my dependent variable, the life expectancy for countries, there it is, when our independent variable is 0, with a 0 birth rate is, and here's my A value, 105.4 years. So 105.4, that was my A value, you can see that up here, that's my A value. On average, the life expectancy for countries with a 0 birth rate is 105.4 years. We'll just get some practice at doing that.